In this video, we'll be looking at the fundamental theorem of calculus part 2. Now, there is a part 1, but we're not going to cover that until later. It's a little bit more complicated, but in part 2, this allows us to make the connection between the integral and the antiderivative. Again, we've gotten the rules for basic antiderivatives, and we should understand now that there is a comparison between the integral, everything that we've been working with in terms of areas under the curves, and the actual antiderivative function. So, in that case, let's make note, the integral from a to b of f of x dx is nothing more than the antiderivative, and again, make sure you note that capital F is the antiderivative of lowercase f, the function f. Okay, so this is the antiderivative at b minus the antiderivative at a. Now, one of the common mistakes that are made is that we plug in these bounds wrong. Notice, it's the f of b, it's the upper bound, minus f of a, the lower bound. So, if I'm going to use the fundamental theorem of calculus here to evaluate this integral, my first step is to identify what is the antiderivative. Now, keep in mind that there is something called a indefinite integral that has no bounds, and remember, this is nothing more than the antiderivative plus a constant. So if I were to try and take the antiderivative of this, again, capital F of x is simply equal to, well, if it's x squared, I do the opposite of what a derivative would do. Now remember, the derivative would take the 2 down in front and subtract 1 from the power. I'm going to do everything that did in the opposite order in the inverse way. So I'm going to increase the power, changing this to x to the b to the power of 3, and then I will divide by that power. Now again, if there were no bounds on this, my indefinite integral would simply be x cubed divided by 3 plus the c. However, over here, my goal is to then plug this in. This is the integral from 0 to 4 of x squared. Now the notation is that I have the antiderivative evaluated from x equals 0 to 4. Okay, so every time I have bounds on my integral, I should be writing it this. Now notice there's no second bracket on this side. There doesn't need to be. This is telling me that this is the function, and I'm evaluating it from 0 to 4. Now when I say that I'm evaluating it from 0 to 4, I'm still utilizing this fundamental theorem of calculus where I anti-differentiate, I plug in b first, and then I subtract from that, plugging in a. So, f of b, that means this function with 4 plugged in. So it's 4 cubed divided by 3 minus, again, now my f of a when I'm plugging in 0. So it's 0 cubed divided by 3. Then my goal is to simplify this, giving me 64 divided by 3. Now this is the exact area under the curve of x squared from 0 to 4. One more time, this is the exact area under the curve of the function x squared from 0 to 4.